This is Unit 3, Day 4, Applications of the Fundamental Theorem of Algebra. And for our polynomial unit, the important fact about this is the number of solutions, both real and complex, always equals the degree of the polynomial. What is the degree? It's simply the highest exponent that you see when you see a polynomial expression. So for instance, down here, for example 1, the degree would be 3. Down here, example 2, since that exponent is 4, the degree would be 4. So that's just saying there's going to be 3 solutions to this equation and 4 solutions, zeros. So if that were equal to 0, there'd be 4 solutions here. What we have to understand, though, is that only a couple of them we're going to be able to get using the calculator. The other ones are going to be complex that we'll have to solve using a quadratic formula or some other method of solving a quadratic. So there's a couple steps that we're going to be able to do first. The first things we want to do is use the graphing calculator to find all the real solutions. And when I say real solutions, I mean zeros. In other words, where does it cross the x-axis? Okay, find all those first, list them out, and then we'll use synthetic division with those zeros. You know, when we put the number in the box and write the numbers along here and divide down. The goal is to get that to be a quadratic, and so that way we can use some method to solve that quadratic. Now sometimes it's going to be the quadratic formula, but not always. But let's write the quadratic formula for those that need to know it. For any solution that says ax squared plus bx plus c equals 0, the quadratic formula to get the solutions for x is x equals opposite of b plus or minus square root b squared minus 4ac all over 2a. And you can remember that song because you'll have to memorize that formula. You say opposite of b, plus or minus square root, b squared minus 4ac, b squared minus 4ac, all over 2a, all over 2a. And hopefully that song will help you remember. There's some other tricks and things that help you remember the quadratic formula too if that song doesn't work. So let's dig in to see how we do example 1. So we'll want to pull up, I like to use Desmos, but you can use your TI calculator as well. Our goal is to get all the roots, which are another name for zeros. So we'll put that in our calculator. We'll do x to the third power plus 2x squared plus 4x plus 8. And on Desmos, you don't really have to do anything other than click the point where it hits the x-axis, and that -2, not the 0, but the -2 would be considered one of the real zeros. So your real zero, real root, is x equals -2. So that's all I need the Desmos calculator for. From there, what I'll do is I'll use synthetic division, and I'm not going to change the sign, so I'm just going to keep that -2 in the box, list down my coefficients. So that's going to be 1, 2, 4, and 8. Complete the synthetic division process, which is always bring down that first number. Take that number and multiply it by the number in the box. 1 times -2 is -2. Add them together, you get 0. 0 times -2 is 0. Add these together, you get 4. 4 times -2 is -8. And that's your remainder. And so remember, this is going to be a quadratic expression since we started with a third power. So it's going to be x squared plus 0x plus 4. And because we want to find the 0, we do want to set that equal to 0 as well. I don't use the quadratic formula when I have 0x because this is really just x squared plus 4 equals 0. And I can simply subtract 4 and take the plus or minus square root to solve that out. That plus or minus is important. I's come in pairs. So we want to make sure that we can have a positive and a negative square root. Now we can't square root a negative number. It's going to give you a non-real answer. However, if you use your TI calculator and you press mode, if your mode is set to a plus bi, then you can square root of negative 4. That's going to just be 2i, because we know the square root of 4 is 2, and that negative is going to pull the I outside of it. So really your answer for the complex portion is going to be plus or minus 2i. So your real 0 is negative 2. Your complex 0, or your complex zeros, that pair would be x equals plus or minus 2i. Together they form all your solutions to that equation. And there should be 3 solutions. 1, negative 2, positive 2i, and negative 2i form your 3 zeros for that. Let's look at example 2. So for example 2, notice that we have a 4th power polynomial. Take a minute to go into Desmos and plug that in and see where they cross the x-axis. I'll give you a second. I'll pause the video. Okay, I plugged this into my Desmos, and I'm going to go ahead and hit those points where it hits the x-axis. And it looks like it's at negative 3 and positive 3. So I'm going to jot those real zeros down. Go ahead and circle that, since those will be 2 of my solutions. My other solutions, I'm going to use synthetic division. And it doesn't matter which one of these you use first. So just pick one. I'll pick, in this case, I'll pick, I guess, negative 3 first. Let me zoom that in better. So I'll put that in the box, and I'll do my coefficients, 1, 1, negative 7, negative 9, and negative 18. All right, bring that line down. At this point, you should be pretty good at synthetic division. So bring down the 1 times, that's negative 3, add down, you're going to get negative 2. Negative 2 times negative 3 is positive 6. Add down, you're going to get negative 1. Negative 1 times negative 3 is 3. Add down, you're going to get negative 6. And negative 6 times negative 3 is positive 18. And your remainder should be 0. Well, I can't solve that because that's not a quadratic yet. That's actually, since we started with the 4th power, that's a 3rd power. That's x cubed minus 2x squared minus 1x minus 6 with a remainder of 0. So I need to take that other real 0 and put that in synthetic division and do it again with my new numbers here. So we're going to ignore that 0 and we're going to take 1, negative 2, negative 1, negative 6 and divide 3 out of that. So bring down the 1, multiply by 3, that's going to give you 3. Add the negative 2 and 3 to get 1. 1 times 3 is 3. Add these down and you're going to get 2. 2 times 3 is 6 with a remainder of 0. Now in this case I have 3 numbers that's going to represent 1x squared plus 1x plus 2. And again, I want to set that equal to 0 since my remainder is 0. In this case, I can't do what I did up here because I don't have a number I can subtract. I have an x I have to figure out how to work with as well. So this is where I'm going to use the quadratic formula. This is going to be my a value, b, and c, 1, 1, and 2. So I'm going to plug that into this formula here to solve. So my opposite of b is going to be negative 1 plus or minus the square root of b squared, 1 squared minus 4 times 1 times 2. b squared minus 4ac all over 2a, so 2 times 1. If you need to use your calculator to assist you with the numbers under the radical, of course that's fine. That's going to give me negative 7. So my solution, before I simplify, it's going to be negative 1 plus or minus the square root of negative 7 over 2. 2 times 1. Well, you can't have a negative in the square root. So even though I can't square root 7, I still have to simplify this and pull out the I. So that's going to be negative 1 plus or minus I squared of 7 over 2. And since I can't break down the 7, that's going to be my answer. So this is going to be my complex 0. Zeros, since it's 2 of them, plus and a minus. It's going to be x equals negative 1 plus or minus I times the square root of 7 all over 2. And two solutions here add up to your highest exponent, which is 4. Okay, go to the backside. Let's look at example 3, and I'll have you try the your turn and we'll check that together. So pause the video and let's go ahead and put this in your calculator. And we'll check that in a second. After having put this expression in Desmos, I get 3 zeros, negative 2, positive 1, and 2. So I'm going to go ahead and jot those down. Those are my real zeros. I don't care if the word says roots, intercepts, solutions. That's all means the same thing. So negative 2, positive 1, and 2. So let's go ahead and circle those. So we're going to have to do synthetic division again. This time we have 3 roots to kind of divide out. So let's be very careful with how we start. Again, it doesn't matter which one you work with first. I tend to just go left to right. So negative 2, and that's going to be 1, negative 1, negative 3, 3, negative 4, and 4. Make a line, drop down your first number, multiply, add down, multiply, add down. Let me adjust that zoom again. Sorry about that. Multiply, add down, multiply, add down, multiply, and add down. We get a remainder of 0, which is a relief because I'm always worried I'm going to miss a sign and mess that up. Since I'm doing it in pen, I'm kind of lucky I got away with that. Next thing, we're going to take the 1. So let's put a 1 there. So again, we're just using the numbers that are in my real solutions. Negative 2. I'm not changing any signs. Let's do it one more time. 1, 1, negative 2, negative 2, 1, 1, negative 2, and remainder of 0. And one more with the 2. Bring down the 1. 1 times 2 is 2. Those add to 0. Those multiply to 0. 1, 2, and your final remainder is 0. And on this problem, we have x squared plus 0x plus 1 equals 0. And remember, when there is no middle term, you can just say x squared plus 1 equals 0 and solve it by subtracting and taking the plus or minus square root. Well, the square root of negative 1 is I. If your mode is set to a plus bi, you can do the square root of negative 1 just to make sure that, hey, that does come out to be I. So that's actually going to equal plus or minus I, 1i. So my complex zeros are going to be x equals plus or minus I. So try this on your own. I'll put the answers, and then if you want to check the work with me in class, you can. So go ahead and try the your turn. Okay, so your final solution for this should be the real zeros negative 1 and 2, got those from the graph, and then I used those for synthetic division to come up with my complex zeros. And you can follow that work along to see how I got those. Just remember that if you have a negative under the square root, it does have an I on the outside. All right, the next video will come over the last examples. So thank you for watching.